Hey guys, so here's the second part to the 5.4 day 1 notes. We're continuing to factor polynomials. Okay, this next one, we have x to the 4th minus 9. Now, before we do anything, we need to make sure is their greatest common factor, meaning do they have anything in common? No, really the only number they have in common is 1, and they don't both have variables, so they can't take anything out. Now, this type of problem, every time you have an x to the 4th, notice we have a binomial, so there's two terms, and we have subtraction. This is something I like to call a difference of squares in disguise. Because the reason is we're going to treat this like if it was a difference of squares, but instead of putting like x and x, because we need to multiply to x to the 4th, we need to make sure that it's actually x squared and x squared. So a difference of squares in disguise means we just basically start off. Now notice, in order to be a difference of squares in disguise, we need a binomial, subtraction, and the a and c value needs to be perfect squares. So the number in front of x to the 4th is a 1, that is a perfect square, and 9 is a perfect square. So I do two sets of parentheses, and as I said, instead of just putting x and x, we're going to do x squared and x squared. And then the square root of 9 is going to be 3. And just like with our difference of squares, one's going to be minus, one's going to be plus. Now we need to be careful because we need to see, can we factor any more? Meaning, because we have this x squared minus, this could be a difference of squares. But remember the criteria. 1, it has to be a binomial. Okay, that checks off. 2, it needs to be subtraction. Okay, that checks off. Now the last one is your a and your c value needs to be perfect squares. Well, the number in front of x squared, which is a 1, that is a perfect square. However, 3 is not. So the x squared minus 3 is not a difference of squares, and we can't really factor this anymore. And then with x squared plus 3, this is definitely not a difference of squares because we're not even subtracting. So notice we can't factor out anymore, so this would just be our final answer. But definitely just be careful with those difference of squares. Okay, let's look at number 6. We have 2x to the 7th minus 32x cubed. Once again, see if these two terms have anything in common. Yes, they both have a 2 and an x cubed in common. So I'm left with x to the 4th minus 16. Okay, x to the 4th minus 16. Can we factor this a little bit more? Yes, notice this is our difference of squares in disguise. It is very important that you notice those different types of factoring patterns because it'll make it a lot easier to factor and to get your answer. Okay, so make sure you bring that 2x cubed down because if you don't and you leave it out, you're not going to get the original problem. Remember with our difference of squares in disguise, we're going to do two sets of parentheses, okay? And we know this is a difference of squares in disguise because notice that it's a binomial, we are subtracting, and the a and c values are perfect squares. So the number in front of x to the 4th is a 1, that's a perfect square, and 16 is a perfect square. Now remember, in order to do this, we need to make sure instead of just putting x and x, we put x squared. Because when we multiply that, that's how we get the x to the 4th. Now let's take the square root of 16. That's going to be 4. And we got a plus and minus. Now we need to see if we can factor any more. Well, of course, with the 2x cubed, we can't. That's just a monomial. X squared plus 4, we can't because this is not a difference of squares. We're adding. But what about the x squared minus 4? This is a difference of squares because we are subtracting. The a and the c values are perfect squares, and this is a binomial. So that means we do have to make sure that we factor even more. So this will be our final answer here. So we're going to have 2x cubed. We have x squared plus 4. And remember, with our difference of squares, we create two sets of parentheses. Since our a value, or the number in front of x squared, is a 1, we just do x and x. And then we take the square root of 4. Square root of 4 is 2. And one's going to be a plus, one's going to be a minus. Okay? And then that'll be our entire factorization. So just be careful with those. Okay, make sure you watch the last part of our 5.4 day 1 notes.